Good day, everyone. Today we will be discussing about a parabola. Last meeting we discussed about a circle and the illustrations of different types of conic sections and degenerate cases. One of the real-life examples of a parabola is the suspension bridge, as you can see on our presentation. Let us now discuss about the parts of a parabola before discussing about the definition of a parabola. This is the parabola opens upward. The first part of this is the vertex. So this is the vertex. Wait. Okay, this is the vertex. And then we can denote this as letter V. Then we also have the focus. This is the focus. So as you can see, this we can denote this as F. So from this one, we can say that from V up to F, or from vertex up to the focus, we have P units. P units. Okay, now we also have the Lattice Rectum. The Lattice Rectum is the segment that passes through the focus from this point up to this point. So from this first endpoint of the Lattice Rectum to this focus, we have 2P. And then from this another endpoint of the Lattice Rectum up to this focus, we also have 2P. So therefore, we can say that the length of the Lattice Rectum of LR is equal to 4P. Next is we have the Directrix. The Directrix is that straight line, red line. So the distance from the Directrix up to the vertex is equal to P also, units. Okay. And from that, we're going to form a straight line. And then we also have the axis of symmetry. The axis of symmetry is the line or the broken line that divides the parabola into two equal parts. As you see, we have the broken line. Next, what is a parabola? Parabola is the locus of points such that the distance from a point to a focus is equal to the distance from the same point and the directrix. So we need to derive the formula for a parabola. So for instance, that we have a parabola opens upward with the vertex at the origin. So therefore, we have the focus 0P because like what I discussed, we have from vertex up to the focus, we have P units. And then we're going to form a straight line. So as you can see, we have a line here, this one. So from this point, PXY, we need to prove that F0P and PXY is equal to PXY and B directrix, which is X negative P. Okay, so now, by distance formula, we have D is equal to Y sub 2 minus Y sub 1 squared plus the quantity X sub 2 minus X sub 1 squared. Now, by substitution property, we can have quantity X minus 0 squared plus the quantity Y minus P squared. Because the focus is located at 0P and the point is located at XY. So therefore, instead of writing X sub 1, we write X. Instead of writing Y sub 1, we write Y. Instead of writing X sub 2, we write 0. And instead of writing Y sub 2, we write P. So that's the reason why we have X minus 0 quantity squared plus quantity Y minus P squared is equal to, so for this line, we have P, which is located at XY, and the directrix, which is located at X negative P. So now, by substitution property, we have the square root of X minus X squared plus the quantity Y minus negative P squared. Now, next is we have X minus 0 is equal to X squared. Bring down plus Y minus P. We cannot solve this one. That's why we're going to bring down Y minus P squared is equal to X minus X, which is 0 squared. And y minus negative p, since we have double negation here, it will be plus. So therefore, we have y plus p squared. Why there is no square root at all? Because since the two sides have square root, therefore, we're going to cancel the square root on both sides. Next, we're going to simplify quantity y minus p squared and the quantity y plus p squared. Using the square of binomial, we have y squared minus 2py plus p squared, and we bring down x squared. So 0 squared is 0, that's why we're going to simplify y plus p quantity squared. By squaring up binomial, we have y squared plus 2py plus p squared. Again, how are we going to use the square of binomial? To find the square of binomial, or simplifying square of binomial, we're going to have the square root of the first term, which is y squared, the square root of the last term, which is p squared. To find the middle term, we're going to multiply the first and the second term. Y times p is py, times 2 is equal to 2py, and then copy the sign of the middle term. That's the reason why it's negative. Now, combining like terms, we have x squared is equal to 2py plus 2py. Why? Because x squared is bring down. Both sides have y squared. That's the reason why we're going to cancel this one. So let's cancel. And then both sides have p squared. That's why we can cancel this one. Now, by additive property, we're going to subtract negative 2y on both sides, or add 2py to both sides. That's the reason why we're going to have x squared is equal to 2py plus 2py, or by transposition, or we're going to transpose negative 2y to the other side. That's why it will be from negative 2y, it will become positive 2y. So it will be x squared is equal to 2py, bring down, and the negative 2py will become positive 2py. 2py plus 2py is equal to 4py. So that's the reason why we have x squared is equal to 4py. So now, we're going to have, so this is the standard form, the equation of a parabola opening upward. So for this one, here are the formula. For the vertex at the origin, we have the opening. We have four openings: upward, downward, right, and left. For upward, we have x squared equals 4py. For downward, it will only become negative. So therefore, it will become x squared equals negative 4py. If it is located, or the opening is to the right, we have y squared equals 4px. And if it is to the left, it will be y squared equals negative 4px. So take note of that. If it is upward or downward, the variable with squared is x. If it is the opening is from to the right or to the left, the variable with squared is y. For vertex at each k, you will only have x minus y each quantity squared equals 4p quantity y minus k for upward. Quantity x minus h squared equals negative 4p quantity y minus k for downward. To the right, we have y minus k quantity squared equals 4p quantity x minus h. And if it is to the left, we have quantity y minus k squared equals negative 4p quantity x minus h. So as you can see, kapag x, nagkakaroon lang siya ng h. Kapag naman y, nagkakaroon lang siya ng k, or negative k. Next. So here are the patterns that we will be using in order for us to find the other parts of the a parabola, or the coordinates of the parts of a parabola. Let's have an example. So we have y squared equals 28x. First thing that you're going to do, know the orientation. Since it follows y equals 4px, therefore we can say that the opening is to the right. Just always remember, we have four openings: upward, downward, right, and left. It will be upward and downward if the variable with squared is x. It will be right and left if the variable with squared is y. As you can see, the variable with squared is y. Therefore, it can be right or left only. But since it follows positive 4px, therefore, the opening is to the right. Next, by observation, p equals 7. Why? Because as we can see, we have y squared equals 4px. So therefore, 4p is equal to 28. So by this one, we can say that 4p is equal to 28. So by dividing both sides by 4, we can say that p is equal to 7. Okay, next. Let us now find the parts of a parabola. So again, we have the value of p, which is equal to 7. The orientation is to the right. And the vertex is at the origin. Why is it to the origin? As you can see, walang kasama si x, walang kasama si y. So therefore, we have 0, 0. So now, by using the pattern for vertex at the origin, orientation to the right, we will be following the pattern for that. For vertex, we have 0, 0 or the origin. For the focus, we will be using the pattern P0. So by substitution property, instead of writing P, we will be writing 7. So therefore, focus is located at 7, 0. For endpoints of lattice rectum, we will be using the pattern P negative 2P and P2P. For that, we will be having 7, negative 14 and 7, 14. Why? Because P is 7. So therefore, we have negative 2p, which is equal to negative 14. So therefore, endpoints of lattice rectum is located at 7, negative 14, and 7, 14. For equation of directrix, we use the pattern x equals negative p. So therefore, instead of writing p, we will be writing 7. Bring down negative, so it will be x equals negative 7. For equation of the axis of symmetry, we will be having y equals 0. Now, the standard form of the equation of a parabola is equal to y squared equals 28x. To find the general form of the equation of a parabola, we will be transposing 28x to the other side. So therefore, it will be y squared minus 28x equals 0. And that's the general form of the equation of a parabola. Now, let's graph the given parts of a parabola and the parabola itself. So first, we're going to start plotting the vertex. The vertex is located at 0, 0. Now, after that, according to our solution, we have p units. P units to the right because the orientation is to the right. So therefore, we're going to count 7 units to the right. So therefore, the focus will be located at 7, 0. Now, after locating the focus, we have the endpoints of the lattice rectum. According to our discussion, the endpoints of the lattice rectum from the endpoint of the lattice rectum to the focus, that's 2p. So therefore, we're going to count 14 units upward and 14 units downward. That's the reason why we will be having 7, 14 and 7, negative 14. Now, as you can see, we can now form a parabola. But before that, let's have the directrix. For the directrix, we count 7 units to the right because the orientation is to the right of the center or the vertex. So therefore, we will be counting 7 units to the left so that we can now find the directrix. The directrix is located at x equals negative 7. So therefore, we're going to draw a line. That will be our directrix. Next is, we're going to have the axis of symmetry. The axis of symmetry is y equals to 0. Just always remember the axis of symmetry is the line or broken line that divides the parabola into two equal parts. Now we can now draw the parabola. So therefore, this is the graph of y squared equals 28x. Let us now have the next example. The length of the lattice rectum is 12 and the parabola opens to the left with vertex at the origin. First, we're going to have length of the lattice rectum, which is equal to 40. Now, by substitution property, we can say that the length of the lattice rectum is 12 because that is written on the problem. So therefore, it will be 12 equals 4p. Now, in order for us to find the value of p, we will be dividing both sides by 4. So therefore, P equals 3. So now we have P equals 3. The parabola opens to what? So the parabola opens to the left. So therefore, the orientation will be parabola opens to the left. And then the vertex is located at the origin. So using the pattern for vertex at the origin and the orientation is parabola opens to the left, we can have this pattern. First, for the vertex, so vertex is located at the origin. For focus, the formula or the pattern is negative P0. So by substitution property, instead of writing P, we will be writing 3. So therefore, it will be bring down negative, P will become 3, and then bring down 0. That's the reason why focus is located at negative 3, 0. For the endpoints of the lattice rectum, we have negative P, negative 2P, and negative P, 2P. So now, by substitution, instead of writing P, we will be writing 3. So we have negative 3, negative 6. Why it becomes negative 6? Because we have negative 2P. So negative 2 times 3 is 6. That's the reason why it's negative 6. And then N, negative P will become negative 3. And 2P, our P is 3. So 2 times 3 is 6. So that's the reason why we have negative 3, negative 6, and negative 3, 6. Next is for the equation of directrix. Using the pattern x equals p, substituting the value of p, it will become x equals 3. For the equation of the axis of symmetry, it will become y equals 0. So now we have y squared equals negative 12x. Why is it y squared equals negative 12x? It is the standard form of the equation of the parabola because we have y squared equals 4px because the opening is to the left and the vertex is at the origin. Using the formula for vertex at the origin, opening to the left, we have y squared equals negative 4px. Now, since the value of our p is equal to 3, negative 4 times 3 is equal to negative 12. That's the reason why it becomes y squared is equal to negative 12x. Now, in order for us to find the general form of the equation of the parabola, we need to transpose negative 12x to the other side. So therefore, it will become y squared plus 12x is equal to 0. Now, in order for us to graph this one, we're going to start plotting the vertex located at 0, 0. So this is the vertex. And then now, according to our solution, we have P which is equal to 3. So therefore, since the orientation is to the left, we're going to count 3 units to the left of the vertex. So therefore, we have 1, 2, 3. So that's the reason why the focus is located at negative 3, 0. Next, after that, since according to our discussion that the endpoints of the lattice rectum, from the endpoint of the lattice rectum to the focus, we have 2p. So therefore, we're going to count 6 units upward and 6 units downward. Why? Because our p is 3. Since it's 2p, 2 times 3 is 6. So therefore, we're going to count 6 units upward and 6 units downward. So therefore, the endpoints of the lattice rectum will be located here. So we have L sub 1 here and L sub 2 here. Next, after that, we will be counting 3 units to the right of the vertex 0, 0 so that we can get or find or locate the directrix. The directrix is located at x, or the equation of the directrix is x is equal to 3. Why? Because we have p units to the right of the vertex, which is 3. So therefore, counting 3 units, we have 1, 2, 3. That's the reason why we have the directrix x is equal to 3. Now, we're going to draw the axis of symmetry. Again, the axis of symmetry is the line that divides the parabola into two equal parts. So therefore, we have y equals 0. Now, after that, we can now connect the points, and then we can now have the parabola. Next is this one. Let's proceed with the next example. Y squared minus 12y minus 4x plus 28 equals 0. If this will be your given, what are you going to do? You're going to identify what variable has squared. As you can see, the variable that with squared is y. So therefore, lahat ng may y matitira po dito sa side po na ito. So that's the reason why it will be y squared minus 12y equals negative 4x plus 28 will be transposed to the other side. So negative 4x will become 4x and positive 28 will become negative 28. Now we need to use completing the squared in order for us to have a perfect square trinomial. So again, we're going to have b over 2 squared. Our b here is 12. 12 divided by 2 is 6. 6 squared is 36. That's the reason why we're going to add 36 on this side. And then we will also add 36 on this side. Now, by factoring y squared minus 12y plus 36, it will be y minus 6 quantity squared. How does it happen? Again, we discussed this in circle. Get the square root of y squared, which is y. Get the square root of 36, which is 6. Copy the sign of the middle term, which is negative. That's the reason why it will become y minus 6 quantity squared. Now, it will be negative 28 plus 36 is 8. So, that's the reason why we have 4x plus 8. Why it becomes 4 quantity x plus 2. As you can see, by common monomial factor, or we need to get 4 outside because kailangang matira lang dito ay x. So, therefore, we have 4 quantity x. So, 8 divided by 4 is 2. That's the reason why we have 4 quantity x plus 2. For instance, we have 3x plus 7. So therefore, we're going to have 3 as your number outside the parentheses. And then 3x divided by 3 is x. 7 divided by 3 is 7 over 3. So it will be 3 quantity x plus 7 over 3. Okay, let's erase first this one. Okay, let's now have the discussion. Next. Therefore, we can say that the length of the lattice rectum is equal to 4p. So therefore, by substitution property, our length of lattice rectum is this one, 4. Because that's outside the parentheses. So therefore, 4 is equal to 4p, dividing both sides by 4, our p is equal to 1. Now, we have p equals to 1. Let's now check the vertex. As you can see, the vertex is at edge k. Edge, ito po yung laging kasama ni x. As you can see, ang kasama ni x ay positive 2. Negating positive 2, it will be negative 2. Next, ang k ay laging kasama ni y. As you can see, ang kasama ni y ay negative 6. Negating that, it will be positive 6. So therefore, our vertex is located at negative 2, 6. Now, what will be the opening? The opening will be to the right. Why is it to the right? Because it follows the pattern y minus k quantity squared equals 4p quantity x minus h. So as you can see, since yung may squared ay yung y, therefore mamimili lang tayo if it is to the right or to the left. But since the other side is positive, therefore it will be to the right. Now, we can say that we have p equals 1, h equals negative 2, and k equals 6. Using the pattern opening to the right, vertex at edge k, we can have this one. For vertex, we have edge k, which is negative 2, 6. Next, for focus, we have h plus p, k. By substitution property, instead of writing h, we will be writing negative 2. Instead of writing p, we will be writing 1. So negative 2 plus 1 is 1. Negative 1. And then k is 6. So bring down 6. So therefore, focus is located at negative 1, 6. Next, for endpoints of lattice rectum, we will be using the pattern for L sub 1, h plus p, k minus 2p. And for L sub 2, we have h plus p, k plus 2p. Now, by substitution property, instead of writing h, we will be writing negative 2. And instead of writing p, we will be writing 1. So, negative 2 plus 1 is negative 1. Next, we have k minus 2p. Our k is 6 and our 2p is equal to 2 because p is 1, 2 times 1 is 2. 6 minus 2 is 4. So therefore, our first endpoint of the latus rectum is located at negative 1, 4. For the second endpoint of the latus rectum, instead of writing h, we have negative 2. So we have negative 2 plus 1 and 6 plus 2. Now, negative 2 plus 1 is negative 1 and 6 plus 2 is 8. Therefore, we can say that the second endpoint of the latus rectum is located at negative 1, 8. For the equation of the directrix, using the formula or pattern x equals h minus p, by substitution property, instead of writing h, we will be writing negative 2. And instead of writing p, we will be writing 1. So negative 2 minus 1 is equal to negative 3. So therefore, the equation of the directrix is x equals negative 3. For the equation of the axis of symmetry, we have y equals k. Instead of writing k, we will be writing 6. So therefore, the equation of the axis of symmetry is y equals 6. Let us now graph the given parabola. Now, the first thing that we will be doing is we're going to plot the vertex. The vertex is located at negative 2, 6. Now, according to our given, the parabola opens to the right, and our p is equal to 1. So, therefore, we're going to count 1 unit to the right of the vertex. So, that's the reason why the focus is located here. Negative 1, 6. Now, to find the endpoints of the latus rectum, again, the endpoints of the latus rectum, from endpoint of the latus rectum to the focus, we have 2p. Our p is equal to 1. So, 2 times 1 is 2. So, therefore, we're going to count 2 units upward and 2 units downward of the focus. So, therefore, the first endpoint of the latus rectum is located here, and the second endpoint of the latus rectum will be located here. Now, after that, since we count 1 unit to the right of the vertex to locate the focus, kasulungat ngayon para makuha natin yung directrix. So, we will be counting 1 unit to the left of the vertex so that we can locate the directrix. So, the directrix will be located, or the equation of the directrix will be x equals negative 3. Why? Because this is negative 2 in x. This is negative 1. So therefore, if we're going to count 1 unit to the left of the vertex, it will be located here. So now, drawing a straight line, we can have x equals negative 3. Now, to find the equation of the axis of symmetry, we're going to draw a broken line. Now, after that, equation of the axis of symmetry will be y equals 6, and then we're going to draw the parabola. Let's try another example. A parabola with focus at 2, 5 and directrix y equals negative 1. Okay. The first thing that we will be doing is to draw a Cartesian plane. After drawing a Cartesian plane, we're going to locate the focus, which is our given. The focus is located at 2, 5. And then from that, we're going to draw also the directrix, which is y equals negative 1. Now, the first thing that we will be doing, we're going to find the center or the midpoint of focus and the directrix. As you can see, we have 6 units from the focus up to the directrix. 6 divided by 2 is equal to 3. So, therefore, the vertex will be located at 2, 2. Why? Because 2, 2 is the midpoint from the focus up to y equals -1. How did we get that? We first count the units of or the distance from focus up to the directrix, and that is 6. 6 divided by 2 is equal to 3. Therefore, we're going to count 3 units downward of the focus. So therefore, from 2, 5, it will be 2, 2. So therefore, we have vertex located at 2, 2. Now, we can now identify the value of P here. Since according to our definition, from vertex up to the focus, we have P units. And we can see that the distance from vertex up to focus, we have 3. So now we can get the endpoints of the lattice rectum. Because by definition, the endpoint of the lattice rectum to the focus, we have 2P. So 2 times 3 is equal to 6. So therefore, we're going to count 6 units to the right and 6 units to the left of the focus. So therefore, the endpoints of the lattice rectum will be located at -4, 5 and 8, 5. How did we get that? This is the focus. We count 6 units to the right of the focus. So we have 2, 3, 4, 5, 6, 7, 8. Next, we have -4, 5. So we're going to count 6 units to the left of the focus. That's the reason why we arrive with -4, 5. Now, we also have the equation of the axis of symmetry, which is x equals 2. Again, the axis of symmetry is the broken line that passes through the focus and vertex, or it is the broken line that divides the parabola into 2 equal parts. Then from that, we can now draw a parabola. So now the question is, we already have the parts of the parabola. The question is, how are we going to find the standard form and general form of the equation of a parabola? First, we're going to write the opening. The opening will be upward. Next, the vertex is located at 2, 2. So therefore, our h is equal to 2 and k equals to 2. And the value of p is equal to 3. These 3 salient features of the parabola will be very vital in order for us to find the standard form and general form of the equation of a parabola. So here is the formula for opening upward and with vertex at hk. So we have x minus h quantity squared equals 4p quantity y minus k. Now, by substitution property, we have quantity x minus 2 squared equals 4 times 3 quantity y minus 2. Again, how did we get that? Again, our vertex is located at 2, 2. So therefore, our h is equal to 2 and our k is equal to 2. Based on our illustration, our p is equal to 3. So by substitution, instead of writing p, we will be writing 3. Now, 4 times 3 is equal to 12. That's the reason why the standard form of the equation of a parabola is quantity x minus 2 squared is equal to 12 quantity y minus 2. Now, to find the general form of the equation of a parabola, we're going to expand quantity x minus 2 squared. So by square of binomial, we have x squared minus 4x plus 4. Again, how did we get this? Square the first term, which is x, so we have x squared. Square the second term, 2. 2 squared is equal to 4. Copy the sign of the middle term. To know the value of the middle term, multiply the first term to the second term. X times 2 is 2x. Times 2, we have 4x. That's the reason why we have x squared minus 4x plus 4. And then for the other side, we're going to distribute 12 inside the parentheses. So 12 times y is 12y. And 12 times -2 is -24. Now, we're going to transpose 12y minus 24 to the other side. So therefore, it will be x squared minus 4x minus 12y plus 28 equals 0. How did we get 28? Because once we transpose -24, it will become positive 24. So since we also have constant term here, 4 plus 24, we have 28. Okay, that's all for our discussion about a parabola. Thank you and happy math learning. So again, don't forget to subscribe on our channel, hit the notification bell button so that you will be updated with our video tutorial. Thank you and God bless everyone.